Jai Hind. I am Madhup Agrawal, Assistant Professor IT Department in Akgec Department. Today's our topic is sorting, which is a important topic related to programming. And first we know what is sorting problem. In the sorting there are some input sequence, a sequence of n number, let a1, a2, a3 up to an, and as an output we reorder these quantities a1, a2 up to an and arrange these items in such a manner that a1 is less than equal to a2 or and less than equal to a3 and so on up to, means we arrange in increasing order. This is output. Also we can arrange these items in descending order, means a1 may be greater, means two types of output possible, either in increasing order or in decreasing order. So this is sorting. So how to perform these sortings and why to perform sorting? So first, why study sorting algorithms? There are variety of situations that we can encounter, such as, do we have randomly ordered key? Randomly ordered key if we have, then arrange in the order form, in the sequence. So we require the sorting techniques. And are all keys distinct? If we identify all the keys are distinct or not, so first we arrange these items in a sequence in ascending or in descending order, and then find the different keys, are duplicate keys are there or not. And with reference to the sorting, some definitions are there, just like internal sort, external sort, in place sort. We see in the sequence. First, what is internal sort? Means during the sorting process, if the data to be sorted is all stored in the computer's main memory. There are two types of memory. First is main memory and then external or secondary memory. If all the data which is to be sorted kept in the main memory means it is in RAM. So these type of sorting that are performed in the internal main memory are known as internal sorting techniques or internal sort. And next is external sort. Some of the data to be sorted might be stored in some external device, such as in the hard disk or in other devices, which is slower than RAM. So in that technique we must use the external sort techniques. And in place sorting, in this scenario, in place sorting, the amount of extra space required to sort the data is constant with the input size. Means during the sorting process we need not require much more. Much more means with respect to n. If there are n data, then in sorting process we doesn't require the additional storage with respect to n. Some constant storage may be required, maybe 2, 3, 10, but not reference to the number of element. They are a constant time. So this type of sorting is called in place sorting, means at that particular place we can sort where data is already present. Now another is stable sort. What is stable sort? A stable sort preserves relative order of the record with equal keys. If during the sorting there are equal keys, just as example here, this Aaron, this Andrews, Battle, and this one, we are going to sort according to the second field. Now these are records, and if we sort our data according to the second field, that is a quantity, and after sorting if we get the data here, such as this one, and here 1 1 2 3 3 3 4 4 4. Just take example in the case of 3. First this 3, first 3 is Kenaga. Where is Kenaga here? This one. But before this Kenaga, that is another Andrews, before that preserves. In the input this record is before this Kenaga, but here after sorting Kenaga comes before this Andrews. So this is not a stable sort. If the relative sequence preserved in the sorting sequences, then that is the stable sort property. But in this case, this is not a stable sort, because relative sequence have been changed. So some algos or some techniques suitable for stable sort means perform according to the stable sort. Some may not perform according to the stable sort. So this property of sorting keep in mind. Now a technique, there are many algos of sorting techniques such as insertion sort, selection sort, bubble sort, merge sort, quick sort, many other techniques. Here we will discuss two sorting techniques, insertion sort and selection sort. So first we see the insertion sort here. So how to perform the insertion sort? So basic idea is like sorting a hand of playing cards. If we keep if we are playing a cards, then first arrange these cards in our hand. So how to arrange these cards? Start with the empty left hand, no card is here, empty left hand, card facing down to the table, another card. Remove one card from the table, keep the one card and insert it into the correct position in the left hand where it is situated, we will see, and compare it with each of the card already in the hand from right to left. The card held in the left hand are sorted. These cards were originally the top cards of the pile of the table. Now let us see with this figure. Insertion sort. Let in our left hand we keep the cards 6, 10, 24, 36. Left hand cards are in sorted order. Which card? And in the table, if we pick the 12. We pick the 12 and arrange these 12s in our hand cards which are sorted. So first we compare this 12 with the 36 from the right side. 12 with the 36, 36 is greater than 12. So make the space for this 12. Now compare this 12 with the 24. So 24 already greater than 12. So make the place for 12 here. Now compare it with the 10. 10 is less than 12. So proper position of 12 is here between 10 and 24. So place the 12 here. Place the 12 in this position. So main scenario of insertion sort is this one, just like the playing cards. Now see with another example. If we are having these numbers 5, 2, 4, 6, 1, 3. So first card, one card in hand, no need to sort. So pick the card from here. These cards are these numbers, just guess in the at the position of table, and at the top card is 2. So compare this 2 with, or place this 2 in the hand card, that is array position cards. So compare 2 and 5. So place this 2 here and 5. Now in hand we have 2 cards, 2 and 5 in sorted sequence, and in the table we have 4, 6, 1, 3. These data actually are in the array. We are comparing it with the table and hands, so easy to understand. Now place this 4 at the position in this sorted one. Now 4 is less than 5, so position is before 5. Now 4 is greater than 2, so actual position of 4 is between 2 and 5. This is 2 and 5. Now 3 cards in hand are in sorted order. Now pick the next card from table or from this remaining array. 6 compare it with the 5. 6 is greater than 5, so just place here, no need to compare further. Now pick the 1. Now compare 1 with this 6, 1 with this 5, 5 with this, 1 with this 4, 1 is with this 2. So proper position of 1 is in the beginning of the cards, 1, 2, 4, 5, 6. Now pick the 3, compare it with 6, then 5, then 4, then 2. So 3 is greater than 2 and less than 4. Now place this 3 at here. Now no card left remaining. So this is our sorted sequence. According to this sorting, this is insertion sort. Just see here also. These sequences are given. Okay. These are the swappings. These data are in the array. This is the array form. Okay. Now, so in the form of algo, how to write this? These steps, our sorting, insertion sort. A is our data, group of data in the array, that is A. So for J, start from where? One card is in hand. Start from where? 2 to last position. If we have n data, total n data, so from 2 to n, from this 2 to n, A data here 2 to 8. These cards are, pick one card here. With this particular for J loop, we are picking the card from 2 index, 3 index, 4 index. Here we are guessing our index start from 1. If we apply it in C programming, then that is 0. So update according to this one. Now pick the card, do key AJ, pick a value, just let A2 and assign it into the key. Now insert AJ into the sorted sequence AJ minus 1. If we are just guess A is this one, so place this A2 in the so I start from J minus 1. Just guess J minus 1 means start from the extreme right position. So extreme right position is, if this is J, this is J minus, so this is J minus 1. So start with the J minus 1. Now J minus 1, this loop will iterate. We are comparing this one by one till what situation? When I is greater than 0, maximum. I is in decreasing, I is I minus 1, so I must be greater than 0, because the last first index position is 1. So decreasing, one decreasing, maximum we can decrease up to one index number. So this is our termination condition, and AI is greater than key. So compare kar rahe, in the comparing situation AI must be greater than key. Now AI plus 1, if this situation become true, means we are replacing AI plus 1, we are throwing this AI element, we are throwing this AI element to the right position, to the I plus 1 position here, and after throwing we are decreasing the ith index, and this is in loop, this is in the loop position, and after coming outside from this while loop, we are placing our key, where I plus 1 position. Just with the help of example, just see with the help of the card example. Just now we are picking a card. This is a J loop, jth position, and this is the ith loop. First I is J minus 1 position. Start from J minus 1 position up to maximum is reachability is this one. This card index is 1, and in between if we get the position, so at that position this key is greater than the particular ith position element. Just 36 is greater than this particular I position, 36 is greater than 12. So we are proceeding this 36 to the next position, means I plus, at the I plus 1 position we are keeping the element of I, so this 36. Now again I minus minus, I minus minus come this side. Now compare this with the 24. This 24 is greater than this 12, and we are not reaching this one, so we are throwing this element to the right position, this one. Now comparing I minus minus, now this element we get. Now this ith element is greater than this particular key, so place this card at which position? This is the I position and this is I plus 1 position. So keep this card at the I plus 1 position here. This is the proper place for this particular key value. So we are doing with the help of this one. We are keeping this key at the position I plus 1. So insertion sort of the element in place. We are not using too much extra space. We are sorting element in the original position. So this is in place sorting technique. So the summary for the insertion sort. What is the advantage? Good running type for almost sorting, means in the best case we are comparing only n element, so this is the best case, and disadvantage worst case. This is the worst and average case. We find the n square running time. If we have a totally unsorted array and we are going to sort the array, so that is the worst case. In that particular worst case, for each element we are keeping our element at the beginning, again and again at the beginning, means n plus 1 means ordering of n square, we are saying this one. So this was the insertion sort. Now another sorting technique, that is the selection sort. So how to perform the selection sort? Now the basic idea for this one. Selection sort. Find the smallest element in the array. First find the smallest element in the array and extend it with the element in the first position. Extend. Find the second smallest element and exchange it with the second position, and proceed this until the array is sorted. So find the smallest, place the first position, find the second smallest, place the second position, third smallest, place the third position. So how to pick the smallest element, how in the remaining one? So we will going through. Just see with the help of example. If we guess this is our data, so what is the smallest element in this particular array? This is 8, no, 4, no, 6, no, 9, no, this is 1. So place this one at the first position, that is 8, means place means exchange, we are going to exchange. Now 1 come in the first position and this particular 8 in the at the place of 1. So we are swapping the 1 and 8, remaining are same. Now this is the name as it is, selection sort. What is the name? We are selecting the position, and pick the appropriate element for that particular position. So this is the selection sort idea. Now next position is this one, fourth position, means at the second position we have 4. Now the remaining element are 4, 6, 9, 2, 3, 8. So what is the smallest element in this remaining part? That is 2. So pick the 2 and 4, exchange the 2 and 4, exchange the 2 and 4. Now remaining element, this is sorted part, this is unsorted part, this is highlighted part, sorted, unhighlighted part, unsorted. Now pick the smallest one here for this particular position, third position, that is 3. Now place the 3, swap the 3 and 6, swap the 3 and 6. Now 1, 2, 3 sorted, and unsorted part is 9, 4, 6, 8. Now pick the smallest among 9, 4, 6, 8, that is 4. So swap 9 and 4 here. 9 and 4 here. Now 9, 6 and 8, pick the smallest from the 9, 6, 8 and place at the 5th position. At the 5th position 9, we are swapping 9 and 6, 9 and 6. Now this is sorted and this is unsorted. Pick the smallest one from 8 and 9, which is 8, and place the here. So now no need to going further because at the 9th this position we have only one element, so no need to compare it with it. Now this is the sorted one. This is the example for selection sort. Now selection sort algorithm. This scenario is converted into the written form, that is the algo. So perform the selection sort on the given set of data. Let this is A. Now length of A is n. Total n number of elements are there. So for J, this is giving the position. J start from 1 to n minus 1. N minus 1. So 1 position and n minus 1 position. We must choose n minus 1 element. Nth position element is fixed already. No need to go there. So from 1 to n. Now at the jth position first smallest, initialize the index number where our smallest number present. Just let in the starting, that is the smallest number at the jth position, smallest number. And now go from j plus 1 to n. If we are picking this position, so go from j plus 1 position to last, that is n. J plus 1 to nth position. Now compare the element present at the this ith position and this smallest position. Compare it. If smallest position element is greater than the element present at the ith position, then what to do? Just assign the index I to the smallest index. Just change the smallest index where the smallest element present. This is repeated from j to j plus 1 to n. First from here, this is smallest one. Just let this is smallest one. Now smallest one. Now smallest one is this. Just point here. Smallest is no. Smallest is this. No. Smallest is this at this point. So keep the smallest position here. This is smallest. No. Compared with 2. This is smallest. Yes. This is smallest from this position element, that is 2. So point here. At the last, what to do? Just swap the position at this particular jth position for which we are selecting the element jth position and this particular smallest position element which is indicated, and swap this one. This is exchange these elements. So with this scenario we are swapping, and thank you very much.